2.3 linear functions and slopes preparation. Okay, so first the idea of a slope is rise over run, which basically means how much is it going to go either up or down, up if positive, down if negative, and then how much does it go left to right, to the left is negative, to the right is positive. Okay, so we're going to put the rise up and down over the run left to right. So since it rose 5, we have a 5 right here. Since it had 3 to the right, that's positive, that's where we got the 3 in the denominator, rise over run. Let's look at the other one. Now in this case, it looks like it went down 4, which is where you get this negative 4 right here, right? Negative 4. And then it goes to the right 4, and that is a positive 4. And if we're trying to do rise over run, right, m is equal to rise over run, we will put the negative 4, because it went down 4, over the positive 4. Then when we would reduce it, and we get a negative 1. Now, yeah. Okay. So you do have a formula for this. We're going to do a few more visually first, though. Okay, so in this case, what I was going to say is that this, you read it from left to right like you do English, right? So when they're talking about rise over run, and when they're talking about slope in general, they're talking about left to right. Okay, so it is a positive slope if from left to right it goes up, and it's a negative slope if from left to right the height decreases. Okay, so they're always talking about left to right when they're talking about the slope either being positive or negative. So from left to right, if it went up, positive. Left to right, it went down, negative slope. Okay, so find the slope. Okay, so you can see from here to there and from there to there, right? So the distance from here to here, okay, is 3. And then the distance from here to here is 2. So since it went up 3 and then went to the right 2, and I know slope is rise over run. Rise over run. We'll get more details on this a little bit. Then what we would say is this is the rise of 3 over the run of 2. Right? So again, rise is over here, and then the run is over here. So again, it's up and down over left to right. Okay, so like we did before, it was rise over run. But now we're going to come up with a formula for it. Okay. Now to find out the rise, we would have to find out the change in the y values. So again, the rise is the change in the y values. And how do you figure out the change? The change in the y's? Well, you would take the difference. Okay? So if I start off at -1 and I end up at 3, then it went up 4. That was the difference of 4. And how do you find the difference? The difference in the x's? Well, you would subtract. You would find the difference in the x's, and that would give you your run. So the difference in the y's will give you your rise. The difference in the y's will give you your rise, and the difference in the x values will give you your run. Okay, and that's how you come up with this formula right here. So the slope formula is y2 minus y1 over x2 minus x1. And we're going to use m to represent the slope right there in this equation right here. Okay, now you can label your points if you want to. So for instance, if you have 0.1, that gives you x1 and y1. And if this was 0.2, that would give you x2 and y2. So let's try to find the slope. Now, if you're pretty good with your math, you could say, well, if it starts up at 7 for the y value over here, and then it ends up at -2 for your y value over here, it must have gone down 9. And then you could look over here at your x value, and if you start at -4 for your x value, and you end up at a +1, it must have gone up 5. So if you're pretty good with your math, you could just do it mentally like that. But let's see if we just use the formula, okay? So let's start with the formula. So the formula for the slope is y2 minus y1 over x2 minus x1. Now we plug everything in. Now, I recommend to begin with, you probably want to label everything thoroughly, because one of the most common mistakes on this is people get their numbers mixed up. They plug in the x1 for x2, they plug in the y's in the wrong places. So by labeling everything thoroughly, generally speaking, you can just plug it in and make fewer mistakes. Okay, so in the formula, we're looking for a y2. Well, where's my y2? It's right here. It's a -2. right? -2. And I'll put a parenthesis to represent substitution. Now, the next one I need is a y1. Where's my y1? It's a 7. I have an x2. What's my x2? Well, x2 is a 1. x1. What's an x1? It's a -4. Then we do simplification, right? So -2 minus 7 is a -9. 1 minus -4 is the same as 1 plus 4, which gives me a 5, which gives me -9/5. So what about the one over here? So we can label everything. 0.1 will give me an x1 and a y1. 0.2 will give me an x2 and a y2. And if we just look at this, we could determine what the slope is. All right. So if you start off a -2 on the y, and then you end up with a 5, you went up 7. And if you start at -9 and you end up with a 12, okay, you went up 21, or that went up 21, right? 9 plus 12 is 21. And then if I simplify that, I would get 1/3. So that's if you could do the mental math, if you're pretty good with arithmetic, right? But let's say you want to use the formula. That's good. You can use the formula. Okay, so first we write down our base formula, y2 minus y1 over x2 minus x1 equals. Now, don't assume they're going to be giving these formulas. You might have to actually memorize these formulas. Now, the best way I know to memorize the formulas, generally speaking, is every time you're about to use a general formula, write it down first. And after you do that, 3 or 4 times, generally speaking, you probably have the formula. Okay, so let's try this. So now we have y2, which it looks like is a 12, minus y1, which it looks like is a -2, over x2, which it looks like it is a, oops, the wrong one, sorry. So when we were looking for y2, it was a 5. Let me fix that 5. There we go. Put that in parentheses, minus, and then we have x1, which is a -9. Okay, so 5 minus -2 is the same as 5 plus 2, which gives me a 7. And 12 minus -9 is the same as 12 plus 9, which gives me a 21. And the greatest common factor of a 7 and a 21 is a 7. So I divide both these by 7, and that gives me 1/3. So the slope is 1/3. Okay. So the orientation of lines with positive and negative slopes. And again, positive and negatives is looking from left to right. If it from left to right it goes up, positive. If from left to right it goes down, negative. Okay, so we want to find the slope. Okay, so let's do a couple more examples of this. So again, we can label everything thoroughly. So let's say this is 0.1, that'd be x1, that'd be y1, and this is 0.2, this would be x2, this would be y2. Now, you might be worried about which one you label as 0.1 or 0.2, but the algebra will work itself out and it doesn't matter. So you could just as easily label the first one as 0.2 and the second one as 0.1 if you prefer. Okay, so if we just look at this 4 to 4, well, the rise was 0, right? The y's did not change, so the rise was 0. Now what about the x values? Well, it doesn't matter at this point. So -5 goes up to 2, that went up 7, but 0 divided by 7 is just 0. So it looks like the slope is going to be 0 on this. So let's verify this with the math. So in this case, what we have is the general formula of y2 minus y1 over x2 minus x1, and we plug everything in. y2 is over here is 4, y1 is also 4, x2 is a 2, x1 is a -5. That gives me a 0 over a 7. And we say 0 divided by 7 is 0. So it confirmed it. Awesome. There's some special qualities of these that we're going to go over in a little bit. So these are special cases kind of slopes. Okay, so let's look at the next one. So in the next one, we can look at the 2, and then we end up with a -4, so that went down 6. And then we look at the x's. X, it went from 6 to 6, so that's 0. Anything divided by 0 is undefined. Undefined. Okay, and that's a special case as well. Well, let's verify that using the math. Let's say slope is y2 minus y1 over x2 minus x1. And then we label everything thoroughly. 0.1, x1, y1, 0.2, x2, y2. Now, Obviously, you don't have to label everything forever. You don't have to write the formula out forever. You do as much work as you need to get the correct answer. At the beginning, when you're working through these problems, you probably want to write down as many steps as possible just to get the hang of everything. But later on, you don't need to label all your points and the x's and y's. You don't even need to write the original formula down. I'm just writing all the steps. I will say if you're making a bunch of mistakes and you're not able to get the correct answer, you probably want to write all the steps. If you're just able to look at the 2 points and come up with the slopes, I mean, you don't need to write any of it down. On a test, though, you probably want to write as many steps as possible to give your teacher a chance to give you as much credit as possible, because they cannot give you partial credit for things that they cannot see. So if you do the entire problem in your head and you just write the answer and it's wrong, you're going to get 0 partial credit because they can't see what you did in your head. Okay, so y2 looks like it is a -4. y1 is a 2. x2 is a 6, and so is x1. So -4 minus 2 is a -6. 6 minus 6 is a 0, and -6 divided by 0 is undefined. So it just confirmed what we did before. Not too bad. And these are the special things you need to memorize about these. So if y is some constant, and they put it right here, b is a constant. So if y is constant, so if y is equal to some constant, okay, that means the slope is going to be 0, and it is going to be a horizontal line. And we want to memorize that. I'm just trying to pull out the information they have in there. I think it's kind of confusing the way they wrote it. Now, if x is equal to some constant, and constants are, 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 right? So those are constants. And the slope is undefined. We know that is a vertical line. And we just want to memorize that.